Okay, so we're going to take a look at the two questions we didn't finish. One of them is very similar to 7A. It's going to be finding an EDA and then making our sketch. So the question here is determine the end behavior asymptote and the vertical asymptotes. In order to find the vertical asymptotes, what are we going to want to do with the denominator to make that easier to see? Factor, yes. Okay, so we definitely want to factor the denominator. And when we factor that, what's going to be the first term in each parenthesis? Yep, you're going to need an x and an x. And what about inside the parentheses? You have a positive in the middle, and you have a negative for your constant.
Minus and plus.
You're going to need a minus and a plus. And now we need two numbers that multiply to give us 3, and they subtract to give me 2. 1 and 3, and it does make a difference where you put them, but the order that they were set in, that is the order you put them in. If you FOIL that, you're going to get 3x minus 1x. That gives you your 2x. Okay, so now we can see that there are how many numbers, excuse me, that make the denominator 0?
2.
2. All right, so let's write down the two vertical asymptotes. What are the two numbers that make the bottom 0?
Negative 3 and 1.
Negative 3 and 1. Okay, let's put those on our graph. Negative 3, 1. Okay, we just put in two vertical asymptotes. That means my graph is going to be separated into how many sections? 3. You're going to have a left, a middle, and a right. Yep. Okay. Now the other thing they want is the EDA. How do you find the EDA? Sometimes you can use synthetic division, but not here. So we're going to have to use long division. All right, let me get, I just need some more space. So we're going to do x squared plus 2x minus 3. We're going to have 2x cubed, 7x squared. And what's going to go after the 7x squared? 0x minus 4. Let's make sure we copied everything right. Looks good. All right. What's 2x cubed divided by x squared? 2x. Multiply that back out. It's 2x cubed. What's 2x times 2x? 4x squared. And 2x times negative 3?
Negative 6x.
Negative 6x. And what are we going to do with those columns?
Subtract them.
Subtract them. 2x cubed minus 2x cubed is gone. What's 7x squared minus 4x squared?
3x squared.
3x squared. And what's 0x minus negative 6x?
Negative 6x. Positive 6x.
Positive 6x. And bring down your 4, our negative 4. It's the 6x and the negative 4 aren't going to matter. They're going to be part of the remainder, but that's not what we need. The last step we need is 3x squared divided by x squared.
It's 3.
Plus 3. That's your EBA. Y equals 2x plus 3. Okay. What's your y-intercept for y equals 2x plus 3?
3.
3. Okay, so let's start with that. And what's the slope? 2 over 1. So you go up 2, right 1. Okay, and I'm going to go down 2, left 1. I'm just doing it bunch of times. And that is my other asymptote. Okay. So now we need some points. We want to plot some points near each asymptote, and then we want to plot some like in the middle, a few to the right, and a few to the left. And we're going to see we end up with 3 sections of a graph here. All right. Let me get all that typed in. When I type it in, what do I need to put in the calculator that's not on the paper?
That's, wait,
Parentheses.
I need parentheses. Okay, no parentheses, graph won't come out right. So 7x squared minus 4, and divide that by x squared plus 2x minus 3. Okay, so let's do second table. I'm going to just get rid of the values I had in there from before. And let's start with our vertical asymptote at -3. What is a value close to -3 if you approach it from the negative side? Yeah?
-3.001.
Yeah, so you can do -3.001, and we are at 1,246. So we're going to be up towards infinity. What's a value that's very close to -3 if you approach it from the positive side? -2.999, and we are at -1,253. We are way down. Okay, so we know what's happening near that asymptote. Let's check the asymptote at 1. What's a value that's close to 1 approaching from the negative side?
9999.
Yep, so you can do 0.999, and we're at -12,000, so that's really far down. And usually it's the opposite on the other side, but let's check. What's a value on the other side of 1?
1.001.
1.0001, and we're at positive 12,500. So way up here. Okay. Now, let's check a couple more points in the middle. What's a good x value that would be in the middle section?
-1.
Okay, we could do -1, and we get -1/4. So -1, -1/4. What's another good x value? 0, just above 1. I think that's pretty good for the middle. So the middle has to go through all those red dots, and it's trapped by all the asymptotes. Okay, it can't leave that section. So it's going to come up, but then it starts to hit that asymptote, and then it starts to hit another asymptote. And it has to go through there. So there's your middle. Let's check what's happening in this section now, to the left. What's an x value that's to the left? 6 would be to the right. Okay, so we can do -6. That'll fit on the graph. -6, just above -9. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, just above -9. So that's really enough, because what's going to happen here is you need to connect those 2 red dots. You can't cross the asymptote. You just have to stay as close as you can to it. So it's kind of going to come down. And then at some point, it kind of has to start to curve, and then start getting closer and closer to the slant asymptote. Okay, so there's the left. Now let's check. It's going to be a little hard because we don't have a lot of graph to work with here. What's an x value that would be in this section?
2.
Well, we can try 2 and see if we're on the graph. Yep, we got that one. 2, 8. what's one more that I could try to do? I could try 3. I'm almost off the graph, but I can still do it. 3. I'm at 9.4. Okay, so now we need to connect those red dots and stay in between the asymptotes. So this is going to kind of come down like this. It's going to turn. It's going to go like that. All those pieces keep continuing forever. Okay, I didn't put arrows on them, but hopefully that was clear. Okay, let's look at the window. I'm going to set, I'm going to do negative 10 to 10 on the x, but I want a little more room on the y max. So I'm going to go up to 20, and you should see the top part a little better. If I go to 10, all you're going to see is that little section right there. That's not really that good. So let's set this to 10, and y min negative 10 I think was fine. I just said 20. Okay, so there's your left section. Looks good. There's the middle, and there's the right section. But I zoomed out so you could see more of it. Any questions on that? So we had 2 verticals, and what do we call that one? I mean, it's an EBA, but what type of EBA was it? That's a slant. Okay, and we did that yesterday. So example 7A and 7B had slant asymptotes. Okay, so last question. So it says to use a calculator and just find a graph of that. Okay. So let's type that in and see what happens. So we get 2x to the 4th plus 7x cubed plus 7x squared plus 2x. Okay. What kind of EBA would you expect there to be in this one? A slant, yes. Why would there be a slant?
Because when you do division, it's going to be like x4 minus x3. That's usually what you do when you do the division. So it's going to leave x1 behind, like 1x behind.
Right. When you do the division here, you'd have an x to the 1st power. So yes, the difference between the top and the bottom degrees is a 1. So there should be a slant. All right, let's start with zoom 6 and just see what we're looking at. I kind of see something on a slant. I'm not seeing a good view of it. I'm starting to see something on a slant here, but it still looks kind of steep. So what I'm going to do is I'm going to set my y max to go a lot higher. We'll go to 40. And let's see if we can start to see something a little bit better in the upper right. Looking for a slant that kind of matches this one in the lower left. Okay, now I'm starting to see it. I don't know if you can tell, but it's starting to curve back down. And it's starting to slant, I think, pretty close to what this left one is doing. So let's set the x max a little higher, and let's set the y min a little bit lower. So let's set the x max to 15, and let's set the y min to like negative 20, and see if we can see the slant now. Yeah, I think we're starting to see the slant. So the slant is like right about like that. That makes sense? There's your slant. Okay, so that's a good window to see the slant. It's also a good window to see what other asymptote. The vertical, yeah. There's a vertical asymptote right here. I don't know exactly what it is, but I'm not worried about it. So I can see the slant, I can see the vertical. That's That's good. But I don't think that this window shows everything that's important. Is there anything that looks maybe kind of like something we need to check out a little bit closer? Yeah?
There's kind of a curve at the top of them, or on the side.
So this part is, it's pretty much just going to kind of, from this point now, it's just going to kind of keep going like that. So there's nothing more on the side that's really going to happen. We couldn't see that curve at first because it kind of looked like it was going to keep going up like that. But we saw that it started to curve back down. And now that we can see that, there's nothing else we really need to check out over here. What, this part?
Yeah, the bottom.
The bottom part?
Yeah, like the bottom C.
So this is really just going to kind of keep going that way, and that's just going to keep going that way. So there isn't really going to be anything else that happens here. So what else is there that we might want to check out a little closer? Yeah?
Is there a hole?
This would be a little tricky to get a hole in because you'd have to do a lot of factoring, and these are pretty complicated to try to factor. So I wouldn't give you something like that level of complexity and have you try to find a hole. It's always a good thing to check for, but that'd be very complicated in this problem. It's something that's easier to maybe check out with the calculator than trying to find a hole. Yeah?
Local min or max?
There's definitely a local max right there. There could be more local mins and maxes though. Where could there be more? But we can't tell.
That section?
The what section?
Like the where it looks like it's on 0?
Yeah, this section right here. Let's check that out. We can't tell what's really happening there. That picture looks flat. It's perfectly flat. Let's zoom in on that and see what it looks like. What would be a good X min and X max to zoom in on that box?
-2 and 0.
Negative, I'm going to go to -3 because I think it's just one more to the left. So we'll go to -3, and what about my X max?
2.
Yeah, like 2 would be over here, 1 would be right there. I think it starts curving up right around 1. So let's go at -3 to 2. All right. Now how about a Y min and a Y max? All right, we could try -1 and 1, and we're going to zoom, and we're going to make the whole screen now just that little section that has a box. Okay, and let's look at what we're looking at now. All right, so now let's look at that and see what's going on. Okay. Can we tell if there are any local mins or maxes?
Well, it looks like on the left side it goes underneath 0.
Okay, kind of looks like it goes underneath 0, so
It's very
maybe.
close.
What could we do to see that better?
Zoom in.
Let's zoom in again. So now, zoom in on that. So remember, this was -1 to 1. What could I set my y-axis to now to zoom in on that piece?
-0.5 and 0.5.
So that would be about here and here. I want to zoom in even closer than that. Yeah, like 0.10, 0.1, and -0.1. That's going to zoom me in really, really close. So -0.1 to 0.1. And now, let's see what that looks like. So remember, we're looking for local mins and maxes. We knew there was a local max right there. But let's see what happens when we zoom in. Okay. So now when we zoom in, what do we see is really happening?
There's 2 mins and 1 max.
Right. So that's something you couldn't see this at all by looking at the big picture. Right? The big picture was good to see the slant and the vertical. Because now that I'm zoomed in, I can't see the slant at all. but I can see that there are 2 more local minimums and a local maximum. So the point is, when they ask you to find a complete graph, sometimes you need to zoom out to see something that might be off the screen, or you might need to zoom in to see something that's on the screen a little closer. That's the point of that question. Any questions on that one? Okay. So we still have, we got about 20 minutes. So the homework will be the study guide, which I'm going to give you the next 20 minutes to work on. And that's going to cover sections 4.1 and 4.2. Okay, so the study guide is 374142, and it is in that folder on Schoology. So here's the study guide. It's got some questions about finding transformations. So remember, we did the A, the B, the C, and the D, and I told you what each one did. People remember that? Vertical shift, vertical stretch, all that stuff? Okay, so we got a few of those. Describing the behavior near the asymptote, that's what we do on the calculator. So describe what happens as you approach a certain number from both sides. Finding domain, okay, so that's where we look at finding the asymptotes and then say the domain is everything except those. Here, I'm having you find asymptotes, and I'm just asking you for a specific type. Verticals, horizontals, and slants. Remember, if you have a common factor between the top and the bottom, you don't get a vertical asymptote. Instead, you get a what? You get a hole. Okay, so you got to check for that. That's why I made all the numerators pretty easy to factor, and some I even factored for you. Evaluate the limit. That just means tell me what happens as you get close to -4 from the negative side. That's the notation. As you approach -4 from the left, from the negative side. So I got that one. Here's another one. Let's see. Same idea here, except I'm not asking you what happens as you approach a number. I'm asking you what happens as you head to the right forever. What's happening to your graph? It's getting closer to something. This is another one. I'm asking you what happens as you approach the number 1 from the right side. Couple finding the EBM. Another one finding the EBM. And then a couple finding the EBA. You can use synthetic division or long division. And that's a review question from 3.7. Determine the number of solutions and solve. So remember, for that, you got to put them in on your calculator, and you have to find where they intersect. And that's the review for the test. Okay. So any questions on that? Yeah. Yeah, I can do that.